You can know the CCNA topics and still lose time for 3 practical reasons. You hesitate on subnetting, you configure without proving the result, and you memorize commands without understanding what the packet or frame is doing. This video is a current, practical guide to 200-301 CCNA v1.1 as of August 13, 2026. It is not a dump, and it will not invent a passing score or a fixed question count. Instead, we will build habits that survive unfamiliar topologies, timed labs, and questions that ask you to reason. First, identify the exam correctly. Cisco currently lists implementing and administering Cisco solutions, 200-301 CCNA v1.1. It is a single 120-minute exam. The v1.1 blueprint weights network fundamentals and network access at 20% each, IP connectivity at 25, IP services at 10, security fundamentals at 15, and automation and programmability at 10. Cisco says the guidelines are general and can change. The transition is time-sensitive. The last date to test v1.1 is February 2, 2027, and v2.0 first tests February 3, 2027. Recheck Cisco before you book. If your test is before that transition, study the v1.1 blueprint, not rumors about the future version. Practical advice: stop treating subnetting as a recognition trick. Make it a short procedure. For a /27 network, the block size is 32. If the address is 192.0.2.158, the boundaries are 0, 32, 64, 96, 128, 160, and 192. So, the network is 192.0.2.128. The broadcast is 159, and usable hosts are 129 through 158. Write block size, boundary, broadcast, and host range every time. For IPv6, keep the prefix length separate from the interface ID, normalize before compressing, and classify the address before asking whether it is routed. The habit is predict first, then verify with show IP interface brief or show IPv6 interface brief. Here is a switching trap that reveals whether your mental model is solid. A switch learns the source MAC address on ingress. It then looks up the destination MAC. If the destination is known, the switch forwards out the matching port. If it is unknown, the frame is flooded within the VLAN, except back out the port it arrived on. Say it out loud, learn source, look up destination, then filter, forward, or flood. Use show MAC address table after generating traffic. For IPv6, do not search for a broadcast address. Classify global, unique local, link local, multicast, or another defined type. Then ask whether the next hop in scope makes sense. A common troubleshooting mistake is fixing the access VLAN and stopping. Walk the path hop by hop. Does the VLAN exist, and is it active? Is the edge interface really in access mode and assigned to the intended VLAN? Is the trunk operational? Is the VLAN allowed? Do native VLANs agree? Finally, is the Layer 3 gateway reachable? The useful evidence is show VLAN brief, show interfaces trunk, and show interfaces switch port. A compact mental checklist is VLAN exists, edge port, trunk state, allowed and native VLAN, then gateway. If a VLAN works on one switch but not across two, suspect the trunk before rewriting the endpoint configuration. For Ether channel, physical similarity is not enough. Member interfaces need consistent logical settings: access or trunk mode, allowed VLANs, native VLAN, and negotiation. With LACP, channel group 1 mode active is a standard example. But the point is to verify the bundle with show Ether channel summary and show interfaces port channel 1. For rapid PVST+, do not choose an answer by speed alone. For rapid PVST+, do not choose an answer by speed alone. Determine the route bridge first. Then, on each non-route switch, choose the route port by total path cost. Only after that resolve designated and alternate roles, and distinguish a role from a forwarding or blocking state. Port fast is for edge ports. It is not a universal make STP faster command. Verify with show spanning tree VLAN 10. Cisco describes performance-based items as outcome-focused, and its guidance says labs are designed around roughly 5 to 7 minutes. The whole exam is timed, and after you move forward, you cannot return to the previous item. Practical advice: read the tasks, guidelines, and topology before typing. Identify the required end state. Configure minimally. Verify. Then move deliberately. Do not memorize one perfect sequence that only works on one topology. Your repeatable loop is predict, configure, show state, test the data plane, and explain the mismatch. A syntactically accepted command is not proof that the network works. Use show running config as one evidence source, then use ping or traceroute when the objective is reachability. The routing trap is applying administrative distance too early. Forwarding starts with longest prefix match. Imagine routes for the same destination space that include a /16, /24, /25, and a default route. The /25 wins when it matches, even if another route has a numerically attractive administrative distance. Administrative distance compares routes to the same prefix from different sources. The metric compares paths within a routing source. Keep that order: prefix length, then administrative distance, then metric. When reading a static route, state the destination and prefix, how the next hop resolves, and whether the route is intended as primary, default, host, network, or floating backup. Confirm with show IP route and show IP route followed by the destination. Diagnose OSPF from evidence, not memory. Start with interface addressing and status. Check which interfaces run OSPF and which area they use. Inspect neighbor state. Then check network type, DR and BDR behavior where applicable, router ID, and learned routes. The evidence chain is show IP OSPF interface. Brief. Show IP OSPF neighbor. Show IP protocols, and show IP route OSPF. A route problem is not automatically a network statement problem. An adjacency that never forms can be an address, area, timer, network type, or identity issue. The pass habit is to name the broken layer before changing configuration. NAT questions become simpler when you label direction and evidence. Mark inside local, inside global, inside and outside interfaces, the matching condition, and the traffic that should create a translation. Then check show IP NAT translations and show IP NAT statistics. A rule that looks correct can still fail when interfaces lack the inside or outside role, the match is wrong, or no traffic has triggered state. For ACLs, translate every entry into plain language. Check source, destination, protocol, wildcard, interface, and direction. Put specific entries before broad ones. Remember first match, and remember the implicit deny. Use show access lists and show IP interface. Then trace one packet that should pass and one that should be denied. Security features are easier when you draw the trust boundary. Which side is infrastructure and trusted? Which side is the endpoint and untrusted? What evidence does enforcement use? DHCP snooping builds bindings. Dynamic ARP inspection can validate against those bindings. Port security limits learned MAC addresses. The practical trap is enabling a feature without the VLAN scope, trusting an edge port, or forgetting that the trusted direction should face the legitimate DHCP infrastructure. Useful checks include show IP DHCP snooping binding and show IP ARP inspection. Do not memorize feature names as isolated facts. Connect each control to its boundary, evidence, and failure mode. Automation is 10% of V1.1, so do not ignore it, and do not turn it into a software engineering exam. Know that REST maps common CRUD ideas to HTTP methods: get for read, post for create, put or patch for update, and delete for delete. Read valid JSON. An object can contain strings, numbers, booleans, arrays, nested objects, and null. For example, hostname is a string, enabled is a boolean, and interfaces is an array. Distinguish northbound APIs toward applications from southbound APIs toward infrastructure. At capability level, Ansible commonly describes desired tasks and configuration automation. Terraform describes declarative infrastructure provisioning. Also review the V1.1 editions around AI and machine learning. Keep the exam clock in mind. No fixed minutes per question formula is justified because Cisco does not disclose a fixed question count. One of the worst study traps is calibrating readiness to a mythical fixed passing score, an assumed question count, or recalled live questions. Cisco does not publish a fixed passing score, and exam content is confidential. Dumps are not a pass habit. They are a security and policy risk, and they do not build transferable troubleshooting skill. Use the current blueprint as your coverage contract. Use mixed format practice to find weak concepts. Use original labs for action verbs, such as configure and verify. Then revisit every miss by explaining what the device should learn, select, forward, permit, deny, or advertise. Your final recall card is 3 words: blueprint, packets, proof. Blueprint. Cover every V1.1 objective at the verb depth Cisco uses. Core packets. Narrate source learning. VLAN tagging. Spanning tree roles. Longest prefix match. OSPF evidence. NAT direction. ACL order. And the trust boundary. Proof. Show state. Test the data plane. And explain a mismatch. In timed practice, rehearse the decision to move on after a deliberate verification pass. Do not freeze chasing a perfect command sequence. This video is current as of August 13th, 2026. Recheck Cisco's exam page and blueprint before publishing or booking, especially around the February 2nd V1.1 cutoff and February 3rd V2.0 start. Build skill, not a dump.